Okta is the leading independent identity provider for the enterprise, and Okta's Identity Cloud enables organizations to secure and manage their extended infrastructure and transform the customer's experience. With over 5,500 pre-built integrations to applications and infrastructure providers, Okta customers can easily adopt the technologies to fulfill their missions. Currently, we have like 5,100 customers, including JetBlue, Twilio, Slack, etc., and they trust Okta to securely connect their people and technology. So, what does performance engineering do at Okta? So, we are the ones who are mainly responsible for keeping the service up and running. Whenever there is a service degradation or service outage, we are the ones who will be pulled into it and we investigate and fix things. Besides that, we also do capacity planning. Based on the organic growth of a cell, we recommend adding more servers to the tiers or upsize the existing instances. And also, if necessary, we would recommend building more cells if the current cells are already at capacity. We also take care of service protection through rate limiting and background jobs throttling. Besides that, usual performance stuff like MySQL query optimization using explain plans, and now with VividCortex, we get more information for optimization. And other than that, application code optimization and JVM memory optimization. So our monitoring stack comprises of many external and internal tools. The most notable ones are Wavefront, VividCortex, Splunk, and AppDynamics. So Wavefront is our primary source of alerting, and VividCortex is the primary tool that we use for database monitoring, and Splunk it's where we index our logs, and AppDynamics is our application monitoring. So why is database monitoring so important? As everyone knows, database is the heart of the system. If your database does not perform properly, then it will manifest as poor end user experience, which will affect your business drastically. So at Okta, we monitor metrics closely every day, and also we have alerts set up on most important database metrics, and we take actions immediately to avoid outages. Also, we pay special attention to anomalies like sudden database spike or sudden connection count before they become a site-wide impact. So through the rest of my talk, I'll be talking about how we used to do anomaly investigation before VividCortex and how it has changed with VividCortex. So this is one of the typical examples of a database anomaly. As you can see, this is the database CPU from Wavefront. The database CPU spiked from a baseline of 10% to 35%. It lasted for 2 minutes. So it could be due to various reasons. It could be an EBS hardware failure or a poorly performing query scanning tons of rows, or it could be like a sudden burst of short duration queries from any API request or a job. So before we had VividCortex, we just had slow query digest to investigate this. We receive slow query digest every 30 minutes through mail from each of the database hosts. And if you are fortunate enough to find a slow query that aligned with that database spike, we would run explain plans on one of our internal tools and see if there is anything can be optimized. Sometimes the digest may not have the complete query. For example, if the query has like 1,000 parameters in the in class, it gets truncated, so we had to seek ops and DBA to do the work for us. As you can see, this is a long time-consuming process, and also we could not take immediate action because of the long process and the 30 minutes time duration during which we get the slow queries. And the main important thing is we had no visibility on the queries that were less than 1 second. So here 1 second is our slow query threshold, and also the number of queries that ran on the database around the time, and the total time spent by those queries on the database. So in short, we lacked a detailed picture of the database. We had some extent, but not complete picture. And above all, it took us a significant amount of time to track down the issue and fix it. But after we got VividCortex, through the lobbying of our DBAs who strongly believed in the potential of VividCortex, we integrated VividCortex with Wavefront So as you can see, you just need to right-click on the graph and you can directly navigate to VividCortex from Wavefront. This was really helpful for us and saved us a lot of work. So once we do this, so all we did was like right-click on the database graph and you'll get the profiler view, which is a nice view in VividCortex. The time window is automatically set and the host is selected automatically. And all we just need to do is look at these graphs and see if anything stands out. And here you can see we have 2 offending queries. And so if you want to dig further, we can just click on these queries and see if anything we can be optimized. So we are clearly closer to finding the root cause of the query without using any other tools, just VividCortex. So before proceeding further, I wanted to take a small detour and talk about query tagging. Query tags are contextual information that are added as comments to the SQL queries before they hit the database. This contextual information include operation, which is the actual API endpoint or a job, and the request ID or the host ID, host which issued the query, and the user and source. This is the most valuable information for us because this is the actual method in the DAO class that issued the query. So before we had this information added to the comments, added to the queries, we would just grab this query, grep it in the code to find out which class issued the query. But after we added the SQL tags to the comments, to the queries, we were able to reduce a lot of our time to find the actual place in the code. So if we go back to the anomaly detection, which I was talking about, this is the same view as we saw before, but this time this is based on query tags. VividCortex indexes those query tags, and which is the most extensively used thing at Okta, and we really love this feature at Okta because it reduces so much time to tie the actual job or endpoint with the database spike. So you can see for that database spike, we have a clear offender here, and it took us like 3 minutes to find out the issue, but before that, it would take like half an hour or 1 hour maybe to find the issue. So it had improved the productivity of our performance engineers a lot. One more thing that we really like about VividCortex is it provides samples for the queries, and this sample gives us explain plans as well. So we don't have to run the hassle of go to an internal tool, run explain plan, and find out what's the issue with the query. And this is super helpful. And also the samples capture the comments as well. So if you want to dig further, we just need to grab the request ID and go to Splunk and find out what the actual request is and what was it doing. So to summarize, before VividCortex, we lacked a holistic view, which we got with VividCortex. And there are a lot of other useful information like the query samples, in query tags indexing, explain plans, and the most important thing is the volume, the total count of queries during the day. This was really helpful. This significantly reduced our time to identify the root cause. Above all, it easily integrates with our existing monitoring tools like Wavefront. So as I was mentioning before, we integrated VividCortex with Wavefront. I'm going to briefly describe how we did that. Wavefront has a feature called external link, which lets you navigate from Wavefront graph to any external tool you want through an external link URL, which you need to specify. In our case, we just needed to construct the link for the VividCortex, and we just need to fill in details like start time, end time, which is the window in VividCortex, and also the host for which we need to see the graphs in VividCortex. It works like a charm. It's a simple trick, and it helps a lot. So before I conclude, I just wanted to talk about a beta feature that we started using recently, which is the Explorer view. It helps us to directly correlate database CPU with queries, query tags, anything. And this is turning out to be really helpful. During one of our recent issues, we were able to use this tool to find out which queries trend changed. So hopefully we'll be using this a lot in the future.